Good morning, grade 10s. Today we're going to look at factorization and we're specifically focusing on grade 9 revision. So if you could open up your books and write today's date. Today is the 2nd of the 4th, 2020, and we are doing Factorize. And it's revision of grade 9 work. Okay, so briefly so you can remember that factorization consists of many parts, 3 parts actually, is from grade 9. And the first part is finding a highest common factor. What do I mean by common? It's that they both have something in it. And HCF comes in many different forms. So firstly, it's just finding a common factor, which is what you are used to. It is also finding a common bracket, okay, brackets that look exactly the same. It is also sign change, where you change the sign outside a bracket and then the signs inside the first bracket change, and then grouping. Yeah, and grouping always happens when there are 4 terms, okay, and grouping will lead probably to a common bracket. It may first lead to a sign change if you don't group cleverly, but it will definitely lead to a common bracket. And sign change leads to a common bracket, and the common bracket becomes the common factor. Okay, that's what you learned last year. Then after HCF, you look for dots. Difference of 2 squares. That consists of a minus sum between 2 perfect squares. So for example, 16 and x to the power of 6. How do I know a variable is a perfect square? Well, it must have an even power. This would be difference of 2 squares. And thirdly, we've got trinomial, and the trinomial you learnt in grade 9, trinomial, looks like this: x squared plus bx plus c. And those are the 3 ways to factorize. So we're going to do some revision before we move on tomorrow to grade 10 factorization. And we're going to start with the worksheet that you received on Instagram. So can you please write there HCF as the next subheading? And we are going to do example 1. And example 1 says factorize fx plus 10y plus 20z. So 3 terms. What do all of the terms have in common? They all have 5 as a factor, meaning 5 can fit into each one of these. So I take 5 out, and when I take 5 out of here, it actually means I'm dividing each term by 5. What am I left with? X plus 2y plus 4z. And that is our first answer. Right, example 2, I'm actually doing example 4 with you. It says factorize 3b x squared plus 1 minus 10 x squared plus 1. Okay, HCF, what do I see? Common brackets. Brackets that look exactly the same, and that's my HCF. So I take out the common bracket, meaning I divide each term by the bracket. Okay, and what am I left with? On this side, if I take that out, I'm left with 3b. And on this side, what am I left with? If I take it out, minus 10. And then lastly, for HCF, I'm doing example 5. Example 5 looks like this: 3y x minus 1 plus negative x plus 1. What do I notice? I see 2 brackets that are similar but not exactly the same. So in order to do this, I need to do something called sign change. And how does sign change work? If you can remember from last year, you change the sign outside the bracket, and every other sign inside the first bracket also changes signs. So the first term stays the same, 3y x minus 1. I change the sign to a negative, and then the signs inside the first bracket change. So the negative becomes positive x, and the positive 1 becomes negative 1. And what do I notice? I have exactly the same brackets, hence leading to a common bracket. So if it's common, it means that I can take it out as a factor. So I take out my common brackets, meaning that I divide each term by x minus 1, and I divide this by x minus 1. And what am I left with here when I divide by x minus 1? I'm left with 3y. And what am I left with here when I divide by x minus 1? Not 0, but rather 1. Remember, anything divided by itself is 1. 2 divided by 2, 1. 100 divided by 100, 1. A bracket divided by itself, 1. And that is my HCF examples. Taking out an HCF, taking out a common bracket, and doing sign change. Thereafter, we're now going to do dots, which I said was two terms, difference of two squares, and a difference meaning subtracting two perfect squares. So two terms that are each able to be square rooted. So I'm going to do example 1 with you. And it says x squared minus 25. Two terms with a minus sign between them. This is a perfect square and this is a perfect square because its power is even. What do? You open up two sets of brackets and you say plus minus in each bracket. Then you find the square root of the first term. The square root of x squared is x, and you fill it in there. And you find the square root of the second term. Square root of 25 is 5. And that is my answer. You should always check your last bracket, and we'll see an example why. But because there's two terms with a minus sign between them, it could be another dots. In this case, it's not, because neither term is a perfect square. Okay. Example 3. I'm asking you to factorize x squared plus 1. And then you're all going to say that this is a difference of two squares because it's two terms, sorry, my camera, that are both being able to square. But what's wrong here? This is not a minus sign. It's not a difference of two squares. This is a sum of two squares, and I cannot factorize any further, so that is simply my answer. I'm then going to do example 4. It says factorize 18x squared minus 32. And remember that diagram I drew? I said first was HCF, followed by dots or trinomial. This actually means that we should always first look for an HCF even before we do dots and a trinomial, which happens in this case. Because yes, two terms separated by a minus sign, but 18 is not a perfect square and neither is 32. So I couldn't do dots. But what do I notice? Something can go into both of them. What can go into both of them? Sorry, 2 can go into both of them. So I take 2 out. And what am I left with when I take 2 out? If I divide this by 2 and I divide this by 2, I'm left with 9x squared minus 16. And what happens inside of this bracket? Two terms separated by a minus sign. Is this a perfect square? Yes, it is. Is this a perfect square? Yes, it is. So I can do dots. Open up two sets of brackets, just bringing that 2 down. Plus minus, I find the square root of 9x squared, which is 3x and 3x. And then I find the square root of 16, which is 4 and 4. Checking my last bracket, two terms, but they're not perfect squares, so it is not difference of two squares. Right, and the last example I'm going to do with you is example 5. And it says factorize 16x to the power 4 minus 1. Both are perfect squares, so I can open up two sets of brackets. Plus minus. The square root of this is 4x squared. And the square root of 1 is simply 1. Let's check our last bracket. Minus sign, two terms. That's a perfect square because this is an even number. And so is 1. that means that I can do dots within this bracket. I can't do dots here because this is a positive. I'm not doing sum of two squares, I'm only doing difference. So I bring this bracket down, doesn't change. But here I open up two sets of brackets because I can do dots within that. And I've got plus and I've got minus. What is the square root of 4x squared? It's 2x. And the square root of 1 is 1. Checking my last bracket, is that a difference of two squares? No, it's not, because it may be two terms, but I cannot square root 2x. And that is dots. Just going to zoom in a bit so you guys can see a bit better. Okay, and lastly, I'm doing trinomials. And remember I said a trinomial comes in the form of x squared plus bx plus c. That's what you know from grade 9. Grade 10, we're going to make it a bit more difficult. But for now, we're going to look at it like that. So, example 1 says I must factorize x squared minus 7x plus 12. It's a trinomial, 3 terms that look like that. Open up two sets of brackets. The positive tells me that both brackets must have the same sign, and the negative tells me what it must be. You learned this last year, so I'm not going to explain it. X and x, what do? I find the factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. I must subtract one of these factor pairs, one pair of factors, to get to negative 7. Which am I choosing? Negative 3 minus 4. I'm choosing that factor pair. Okay, this you did do in grade 9. That's why I'm not taking a long time in explaining. I'm now looking at example 4. And example 4, I've got 3x squared minus 24x plus 45. Doesn't quite look like this just yet. And what do I notice? That 3 can go into each of those. So I take 3 out as an HCF. Take 3 out, which means I must divide each term by 3. And what am I left with? X squared minus 8x plus 15. And that is a trinomial, I know. Open up two sets of brackets. The plus tells me they must be the same. That negative tells me they must both be negative. X and x. Factive pairs of 15 are just 1 and 15 and 3 and 5. Which pairs am I going to use to get to negative 8? I'm going to use negative 3 minus 5. Okay, I'm actually going to do one more with you just so we're clear. I'm going to do example 2 with you. Sorry, I'm going backwards. I wanted you to do it on your own, but I am just going to do example 2 with you. So example 2 looks like this. It says factorize x squared plus 11x plus 24. Straightforward trinomial, no HCF. The plus tells me that both sides must be the same, but this tells me that they must both be positive. X and x. Factor pairs of 24, 1 and 12. 1 and 24, 2 and 12, and 4 and 6. Okay, which ones am I going to use to add together to get to 11? That's... Oh, I forgot 3 and 8, sorry. Which pairs am I going to use? I'm going to use 3 and 8. So plus 3 and plus 8 gets me to positive 11. Okay. Please remember that if it looks like this, I'm worried that you don't remember, bx plus c, my brackets both have positives. If it looks like this, my brackets both have negatives. But if it looks like this, or if it looks like this, these brackets have a plus and a minus in them. How do I know? Remember, this first plus tells me that both the brackets must have the same sign. And what sign do I choose? That sign. So I give a plus and a plus. Tells me they must have the same sign. What sign do I choose? that sign, negative and negative. This tells me that they must be different. So I don't even consider this. As soon as this is a negative, plus minus, so that's why when I come here, negative tells me they must be different. So I don't even consider this, plus minus immediately. Those are the rules we learned last year. Okay, that is the end of my explanation of factorizing. I just want to make one thing clear. Why do we factorize? Okay, so when we factorize, we create brackets. Who cares? Why would we want to create brackets? Well, generally what we're doing is we're moving from a polynomial, and when we create brackets, we actually form a monomial. If we just look at our very first example that I did, the HCF, we had 5x plus 10y plus 20z. Polynomial, do you agree? They're separated here and here, 3 terms. But when we factorized, we took out a 5 and we were left with this. How many terms do I have here? Terms are separated by pluses and minuses and joined by multiplication or division. It's joined here. This is 1 term. So that's why factorizing is so important, because it moves things from polynomials to monomials. Don't believe me? Let's try one more. In dots, we said x squared minus 25. What happened? Plus minus x and x, 5 and 5. How many terms did we have here? 2 terms. But how many terms do we have here? Joined. 1 term. Why is this so important to move from a polynomial to a monomial? Because remember, eventually when we work with fractions, because yes, we will work with fractions, the only time we're allowed to cancel in a fraction is when I have a monomial over a monomial. So that's why if you have, for example, 8 over 10, what do? You cancel, you simplify. You see that 2 goes into both of them. So 2 goes into their 4 and 2 goes into their 5 times. So your answer is 4 over 5. But what happens if I had, for example, x squared minus 25 all over x plus 5? What do? I've got a polynomial over a polynomial. I'm not allowed to cancel. I'm not allowed to say that x cancels that and 5 goes into there 5 times and my answer is goodness knows what, x minus 5. Okay? You are not allowed to do that. You have to move fractions to be monomials over monomials, and only then are you allowed to cancel. So that's why factorizing is so important, because we must know how to move something from a polynomial to a monomial. And that is the end of today's lesson. If you look at this worksheet over here, the questions I want you to do in your grade 9 revision under HCF is example 2 and example 3. From dots, I want you to do example 2. And in trinomial, I want you to do, I did this with you, so ignore the circle. I want you to do example 3 and example 5. So you can use those as practicing. And then if you look, we put up some more exercises for you to do as part of factorization revision. And what do these look like? Well, exercise 3, I want you to do those numbers, B, E, G, and then question 2, B, D, F, H, I, J, L, N. If we look at exercise 4, I want you to please do for me, let me just get it to focus, sorry. I want you to do I, L, O, P, R. And in exercise 5, I want you to do 1, C, F, I, L, O, and 2, A, C, E. So it's quite a lot of work, but you should be able to move through it very quickly because it is something you should be very familiar with from grade 9. I hope you enjoyed the exercise and that you feel successful in this lesson. See you tomorrow for quadratic expressions, grade 10 trinomial.